Hi everyone, this is Shannon Williams with Rancher Labs. Thank you all for joining us today for our monthly online meetup. We will be having a full crowd today of presenters and looks like attendees as well. And our goal is to introduce you to Rancher 2.2, the latest release of Rancher that we shipped 2 weeks ago. And we're going to be doing that by really spending a lot of time walking through the product in a handful of different demos with many of the engineers who built and worked on the product, kind of explaining to you some of the new features and how to use them. So for those of you who aren't familiar with me, I'm Shannon. I'm one of the founders here at Rancher. I run our sales and marketing team. You can find me on Twitter at SMW355. I am joined by 4 of our engineers, Prachi Damle, who's based in Cupertino. We'll be talking about multi-cluster applications. Jason Van Brackel is the director of community. We'll be talking about networking and monitoring. Rajashree, who's also out in Cupertino, will be talking about catalogs. And Hussein Galal, who works in Egypt, will be walking through some of the work we've been doing around backup and DR. So welcome all of you presenters. Thanks so much for joining us. And again, thank you everyone for attending the meetup today. First things first, we, for those of you who aren't aware, this is really an online meetup, not a webinar. We do a lot of things pretty differently. We've been running these for years. They're very popular because they are both very hands-on. We will be doing lots of demos today. We don't set a hard time limit. This will almost surely run over an hour. I wouldn't be surprised if we go to 90 minutes or so. Questions are really always welcome. There's a questions tab here in the GoToMeeting interface. Write your question. We'll be responding to them. We'll post the responses publicly. Unless you have a very private question, please expect your question to be read out or responded to for everyone else to see. Most importantly, because we're demoing lots of stuff, things may break. Be patient. We'll jump back and forth if we are having any technical issues or technical challenges with the process. The meeting is being recorded. It's the #1 question I get. How would I get this? Can I come back and see it later if I have to run? It will go up on our YouTube channel and on our website. We post these all the time. They end up with thousands of views. If you ever have a question or something you're trying to figure out, there's probably a nice online meetup. You can see from this, most of these, we stick around at the end and answer questions, and often we're answering questions for more than 2 hours, as people kind of bring different challenges and project problems they're maybe having, or different, questions they have about understanding Rancher, Kubernetes, Docker, containers, whatever. One thing I will say is if you're asking a question that's not necessarily germane to the topic we're talking about at the time, your question might not be answered for a while. So don't be surprised if you ask something and we know we're going to be covering it in a little bit. I might just not respond to it. Unfortunately, I can't send you a little note that says I saw it and I will get to it, because then your question disappears. So I have to. Don't be shocked if we don't respond quickly. We typically will get to everything before we wrap up. You are one of thousands of people who are registered to come to these meetings every month. We often have 1,200 people, 1,500 people attending the online meetup. Looks like a huge crowd here today to learn about 2.2 as well. If you want to get to know each other, want to chat, there is a Rancher Meetup hashtag we use on Twitter to introduce ourselves to each other. Please stop a minute, take a picture of you and what you're doing and where you're at, post it, share what you've been up to, how you use Rancher. We'd love to hear it. We also have on our Slack, in the Rancher users Slack. For those of you who don't know, that's at slack.rancher.io. There's also an online meetup channel there where you can kind of dive into longer questions. We usually hang out on there after the meetup if something came up that you'd like to dig into further. So with that, I want to keep moving quickly because we do have a lot to cover today. Our focus is going to be on, like I said, walking you through Rancher 2.2, the latest release of Rancher. Jason is then going to go and talk about some of the monitoring work we've been doing. Rajashree will talk about catalogs. Prachi will get into DNS and multi-cluster apps. And Hussein will talk about BDR. These are some of the big features that are in this release. We won't be covering all of what Rancher does. This is really for, ideally someone who's already somewhat familiar with Rancher, probably using Rancher 2.0 today and looking for more advanced understanding of what's new in this release. So please, if you're kind of looking for an intro to Rancher, we run a weekly training that you can find all over, both recorded versions and our online ones are live every Wednesday morning, I think it is. Yeah, every Thursday morning. So if you're looking for that, we have one tomorrow that I think Jason is giving. So you can always get in there and just get an intro to Rancher, intro to Kubernetes. Today though, we are going to be kind of diving into this in some depth. So be forewarned. With that, welcome everyone to this topic. We're really excited to get into it. 2.2 is a big release. It has a ton of new functionality, really in a couple of major areas. One is around expanding on the concept of multi-cluster application management. We have continuously built Rancher to be a platform that isn't geared to just running one cluster, but can actually manage all of your Kubernetes implementations anywhere that you deploy them. And that's been at the core of Rancher since we released 2.0. In the last year, since 2.0 came out, Rancher has really exploded on the market and become incredibly popular. I think there's now 20,000 daily active, or maybe it's 25,000 if I saw the number right the other day, active deployments of Rancher that teams are using to manage tens of thousands of clusters of Kubernetes and millions of containers. And so thank you all of you who are using it, who are helping us improve it, all of the open source community who have provided fixes and helped us file bugs and improve the product, month after month after month. 2.2 is the second major release of the 2.0 line. Back in the fall, we released 2.1, and now we're releasing 2.2. We basically release Rancher, new point releases of Rancher every 6 months or so. So assume that over the course of 6 months, you'll see a lot of new technology get released in kind of alpha and beta releases, and then all of that will kind of come to market in a GA release with the 2.0, with a point release that we'll do later on. So just at the highest level, when we talk about Rancher, we really think of Rancher as an open source container management platform. It's really servicing three primary goals. One, managing and deploying Kubernetes anywhere that you need it. That means we have the ability to build clusters on bare metal, on VMware, on really any infrastructure you might have. But we also have the ability to manage clusters, and that might mean hosted clusters like GKE or EKS in the cloud, Amazon Azure's AKS, or even imported Kubernetes clusters. So any cluster that's running a conformant version of Kubernetes can be attached to Rancher. And then there's really two elements to what we do on top of it. One is geared towards the IT organization and whoever's responsible for policy about how Kubernetes should be consumed. They tend to find the cluster operations really beneficial, and what allows them to provision clusters and connect it to RBAC and define exactly what Kubernetes looks like in their organization, how to do networking, what type of storage connectors they want to run, how to manage capacity, how to monitor these different clusters that are out there, how to set security policies and enforce them across all the clusters. And a whole nother side is really geared towards the teams that actually consume and use Kubernetes every day in their work, the DevOps teams building applications, whether they are just getting a set of namespaces in a project or they're getting an entire cluster that's kind of allocated to them. We give them this sort of self-service environment where they can see all of the assets they have across all the different Kubernetes clusters running in an organization. They can very easily kind of access those clusters, but also turn on a rich stack of technology like monitoring and logging and alerting, CI/CD, Helm, all sorts of things. And so, we optimize really in these two different directions, building a world-class experience for teams that are actually using Kubernetes and providing the operational framework for the teams that need to manage cluster. And when you look at what we rolled out with 2.2, it really falls into these categories. We're going to talk about things like monitoring and the new capabilities around monitoring, which really apply to both the operators of the cluster and the users of the clusters who are actually deploying applications. We're going to talk about multi-cluster apps, which apply to the operators who might want to deploy something like a security agent across every Kubernetes environment whenever it joins the organization, but it also might be interesting for a user who wants to build an application that spans multiple clusters and can be centrally updated and maintained and using a central Helm chart. So we're going to talk about lots of different capabilities, and they'll both address the user of the namespace, think of it as the person that's actually consuming Kubernetes, and the operations team responsible for keeping it reliable and delivering it as a service. And that's the whole concept of a platform. It kind of services both of these capabilities. For those of you who don't know, Rancher, is 100% open source. Everything we do is available under an Apache license. There's no enterprise version that has a bunch of cool features that you can't use. It's free to everyone. That's why there's tens of thousands of teams that use it. It's really easy to get started with, and we can talk about that when we wrap up. So I want to start by diving right into some of these new features. And the first one we're going to talk about is the new monitoring we introduced with Prometheus. This is a feature that is really exciting. It's done a lot to kind of ease the ability of teams to just turn on Prometheus. But one of the things that's great about it is it maintains not just the version of Prometheus, but also the testing of that version with the different other capabilities and tools that are part of the broader stack. And for this, I want to turn it over to Jason. Jason, do you want to talk a little bit about the new feature and then maybe dive into a demo?
Sure thing.
We can make you the presenter.
Sounds good.
Okay, you're up.
Okay. Can you all see my screen okay?
Yeah, it's coming through loud and clear. JVB-POCS.
Also, awesome. So yeah, let's talk a little bit about monitoring and monitoring specifically. So at scale, you're going to go from a couple of nodes and just scale out and scale out and scale out as you're building out big microservices. And as your application footprint becomes smaller and the number of pieces becomes larger, it becomes really hard to track. And the more of them you have running your infrastructure, the more difficult that gets to be. It's also important for software engineers as they're building out their software to be able to understand what it is they're building, what the dependencies are, and what the resource needs are for that, both at normal load and at high load. That way, you're able to inform Kubernetes as to what resources you need. So that helps the Kubernetes scheduler actually place your applications throughout your mesh to get better utilization in your mesh. And also, a good operations person running a Kubernetes cluster is going to enforce resource quotas, so you can't take all the resources from everyone. With that, let me dive into a demo. Now, what we've done now is made it really easy for you to add monitoring to your Kubernetes clusters. We use two pieces of software. One is Prometheus, and the other is Grafana. Prometheus is a CNCF application stack. It's comprised of a Prometheus server, which is storing things in a TSDB or time series database. So Prometheus is really good at scraping and storing time series data. Specifically, the data inside looks like a timestamp, a metric name, and then a set of key value pair labels. And that's how it differentiates different metrics over time. What that also means is that it's not very good at things like logging. Use your Elastistack or your Splunk that are much better than that. And this isn't the only project out there that does this. It's just the open source one that is managed by CNCF, that is available to you and actually scales pretty nicely. You could certainly use something else if your company's already using a Datadog or something of that nature, a Splunk to do visualization and scraping. Then there's no reason not to keep doing that. This is just another easy button for you to push, coming from zero to Kubernetes and microservices. And Prometheus has actually been part of Rancher for quite a while. If you look over here on this right side here, this Prometheus alerting, the alert manager that ties into PagerDuty, email, etc. If you've used our alerting feature before, you've been using Prometheus. We use Prometheus Alert Manager under the covers to actually control that feature. And of course, over here is Grafana, which is a data visualization tool specific, that actually ties in really nicely with Prometheus, but as well as other data sources like SQL Server, your traditional RDBMSs, and some of your NoSQL databases as well. And as always, after my demo today, feel free to join us on our Slack. Go to slack.rancher.io. You'll get a welcome message from me. And if you have any questions around this, feel free to ask. I'm out there all the time. I am at JVB, that's Juliet Victor Bravo, or hit me up on Twitter. I decided I'll show off my Rancher Meetup tag, and I'm sitting here at my desk in the Philadelphia area. I'm also the organizer of Kubernetes Philly, so if you're out in the area, by all means, come out and see us. So I have 3 clusters here. I will ignore the JVB POCs for now. I use that for all the various pieces of software that I write. Most of that is out on my GitHub as well, also Jason Van Brackel. And I have 2 other clusters here, one with monitoring already turned on because I wanted to have a few minutes to start collecting data, and one where I would just go in and turn on the monitoring feature. There are a number of ways to reach this. So if I go into the cluster itself, you're probably used to this if you've used Rancher before, our aggregate views of the world. And we can enable monitoring here, or we can also get out of tools and monitoring. So let's go into tools and monitoring, and let's enable monitoring. So I'll hit the click button. I now get some options here. Options around data retention in Prometheus, CPU limits and reservations that requires that you actually have that your Kubernetes cluster has the limits admission controller turned on. Ours do by default. I'm going to turn on the node exporter. The node explorer requires special access because it actually has to be able to see metrics on your node. So we're going to turn that on as well. I'm going to enable persistent storage for Grafana. This specific platform is in GKE, so I know I have persistent storage available to me, and for Prometheus as well. So we're actually launching 2 separate applications here that work hand in hand together. Grafana reads Prometheus time series database and PromQL, that's Prometheus query language, to visualize metrics. So I'm going to just grab the default storage class, which is already set up for me in Google, and hit save. And the monitoring is now enabled. And if we go into our system project and watch what's being created over here in the workloads, we can see the cluster monitoring components actually coming up. So generally, if you were to do this by hand, you would need each one of these various components configured accordingly with lots and lots of YAML to stand this up. But in here we have, as I said, it's another easy button for you to push to automatically enable monitoring via Prometheus and Grafana. In addition to that, we've also, on our end, in the Rancher end, we've created a monitoring API. So this allows us to talk to Prometheus metrics and get metrics data and actually show them in our UI, which was in the screenshot that Shannon showed, and I'll show it here in a moment. So I'm going to jump over to the one that's actually had a few minutes to go grab some metrics. And you can see here, this screen has changed. We have a lot more information. This is being fed to us by Prometheus through Metrics Server. So Metrics Server is a Kubernetes component that is exposing metrics about pods and about Kubernetes itself to the user. Prior to that, you might have heard of a project called Heapster. That was the previous generation of tool to do that. And if you go back even further in Kubernetes, you had metrics being surfaced through cAdvisor. So as I mentioned, those metrics are being exposed to us via Prometheus, and you can actually add Prometheus metrics to your applications. I'd recommend doing that because by and large, the metrics are pretty simple and not pretty simple to create and digest. The SDKs around that are very simple, and it looks like GKE has blocked that specific setup. I didn't check my firewall rules, but that's external. From external, internal, it should be working just fine. Otherwise, we wouldn't have the pretty graphs that we do. Now, in addition to that, we've created a bunch of Grafana visualizations. So if I'm going to expand all here, these specific visualizations we're going to see here are all through our monitoring API and our UI development, but they're being scraped from Prometheus itself and are also available to Grafana. So it's not unusual to have a Kubernetes cluster with a lot of Grafana dashboards. And these things can be time-consuming to create. But we've created a whole bunch of them for you that are scoped to this specific cluster or the specific pod. So what's also happening, we've created cluster-level visualizations. We've also created application-level visualizations. I believe I have an application I could show as well. So we have a number of different graphs Now, because this is also backed by persistent storage, I can modify these dashboards. I can modify the data feeds to these graphs. I can get other information out of this cluster that I might need. And the whole point of this is that you know what your cluster looks like when it's running at rest. You know what your cluster looks like when it's running at scale, so that you can create various alerts when there are degrees of separation from the norm, so that you understand when problems are happening before your users understand that problems are happening. The idea is to proactively be able to address scale and spikes in traffic and need as they're occurring. So we can see a number of various things going on that are all just built into Kubernetes cluster itself. I don't think I have but one application running on this cluster, but there are already things going on so that Kubernetes can do Kubernetes things. And by hand, you would either have to download an existing dashboard that somebody else created, or create all these various dashboards and visualizations by hand, which is very time consuming. I spend a lot of time in Grafana crunching various types of data, not just operations data, but data that we see from the community, tracking of the things that we're talking about in the community and where people need help. So, like I said, in addition to operations level visualizations, we also get user level visualizations. So I go into an application that is running on this cluster. I believe I stood up a copy of Redis on this cluster. Sorry, navigates it the wrong way. And now each one of these pods will also have its own visualizations. So if I look at pod level metrics, I can see CPU memory, packets, I/O, both at the network and the disk level, as well as a deeper dive via the visualization. We can see what's going on inside this pod around memory usage, around CPU usage, around network I/O. So that allows your developers in a development scope to actually understand what their applications look like, what their microservices look like, both at rest and at scale. That way, before they go to production, they can set up their deployment specifications in YAML or through their CI/CD systems to let your operations teams know what they need to set appropriate resource requests and limits to make sure the Kubernetes scheduler can do its job well and actually use your mesh effectively, great with ROI. And lastly, besides just visualization, we've also updated our alerting tool. So now, in addition to the alerts we had previously built in, both at the project and at the operator or project and cluster level, we now have additional metrics. Let me go up to the cluster level here because there are more of them here, and go into alerts. And we can see a number of different metrics-based alerts around data that's being pulled from Prometheus. And some of these I would have included in earlier talks I've done around monitoring. They're out on our YouTube channel. But for example, high CPU load is a great one, because we know if we have high CPU load, we likely have a problem. Something's eating the CPU alive. And if I edit this, I could see the PromQL along with the metrics, with its key value pair, the labels, with the by instance, and I can see here CPU by instance over time. Now, here's the threshold. If it's at 100 for greater than 3 minutes, but let's see if I want to just see spikes. I can knock this down to something like, let's say, 45. And now my alert has changed. So if we would see greater than 45 for 3 minutes, an alert would start to fire, and that would attach a notification, which is using Prometheus Alert Manager to send your operations teams or your developers, whoever he needs to know, an alert that something is different about your platform that is not usually the case. So if we know that at rest this platform, or a normal load, this platform is using about 45% of its CPU load, if we go above 45, it may suggest a problem. Then you hit that 45 threshold. Your team gets the alert. They come into the platform and they see they go into the Grafana dashboard. They can see what's using up all of that CPU load, and they can decide what to do about that. If it doesn't have a resource limit around it, you can manually kill it. You can restart it. You could see if something has compromised a container. That way, you can react before all of your CPU gets eaten up, and then your users notice an outage. And that's the idea, is that you see it before they see it. And that's the gist of the monitoring tools that we've added to too. Shannon, do we have any questions out there?
Yeah, there's a whole bunch. Why don't I start with Daniel's? He said, what would be the best way forward if you want to aggregate multi-cluster monitoring of Prometheus to a single Prometheus instance? So if you wanted to kind of track it across multiple clusters and aggregate it.
So if I were doing that, I would actually be scraping all the Prometheus data from the different clusters, probably externally. So actually, the Prometheus overview here has this push gateway. So you can actually pull metrics out of Prometheus and push it to other Prometheuses. So Prometheuses or Promethei, I couldn't tell you. But that way, you could basically ship metrics around via exporters and this push gateway to other areas of metrics collection and actually aggregate that. So we don't have a feature in there that aggregates all of that for you, but it's certainly we have all the tools already built and available to do that. It's just a matter of turning them on.
Great. And then Sten asked a question. He said, "Is there a recommendation for long-term storage of data out of Prometheus?"
Oh, that's a big one right there. Yeah, this generates a lot of data, especially at scale. You treat it like you would treat a traditional RDBMS. You have to regularly rotate your data and have an archive policy. And yeah, really, there are features in Prometheus around being able to compress data and ship data and import data for later, all outside of the scope of what we're talking about today. But it does all of that. That's one of the really cool things about it. This project's been around for a while. It was created by SoundCloud years ago, and then donated to CNCF, and it's now a mature CNCF project.
So in terms of long-term storage, though, I mean, would you say, generally most people, they kind of set a determination on how long they want to keep it, and then, either dump it every, if they're not keeping more than, say, 60 days or 30 days, or they keep it for different metrics, or they push it out to S3 and archive it. I mean, what are you seeing is most common?
Actually, that's really, there's not a lot of variance. It's either you keep it for really short term because this data is generally useful for point in time alerting, but I'm now seeing companies that are looking into machine learning and they're looking into analytics, keeping, say, 90 days worth of data or 30 days worth of data and analyzing that data to find out patterns and how their systems work, how their software works, what their network I/O patterns are, because network I/O patterns suggest traffic spikes. But yeah, it's just one or two things. That data gets stale really fast. Obviously, it's point in time operations data. So as our companies evolve, what we were doing 30 days ago probably doesn't look like what we're doing now. As far as microservices go, and changes in the market, and changes in our product offerings.
Great. Another question was from Spencer. He said, "It sounds like this is using the Prometheus operator under the covers. Is that correct?"
I believe so. I think if we go back into Rancher and we go into System and we look at the apps, that's wrong one. Let's go into this one and System and apps. And there's the monitoring operator right there. Good question.
There's a whole bunch more questions about monitoring that have been coming in. One Nicholas asked if Hipster was required for monitoring. Is it a dependency for Grafana or Prometheus? Do you know the answer to that one?
So maybe it's Heapster. It's Heapster. Heapster was an older monitoring tool that was exposing metrics to tools like Prometheus. Has been superseded in Kubernetes by metrics server. If you look at the GKE cluster is a good example of a cluster that has metrics being pulled by both. So if you look at the things that GKE provides in their clusters, you'll see Heapster running here, as well as metrics server as well. And they're both sending it. They're both exposing different types of metrics. But by and large, metric server has now been superseded by Heapster in all but a few things. Most Kubernetes clusters that are, current versions of Kubernetes won't even include Heapster, and it's not it is not a prerequisite to running Prometheus or Grafana.
Great. Jason, why don't you answer some of the questions that are in the questions tab directly, and you can respond to all so people can see that. I want to get us keep us moving along since we have a lot to cover. So I'm going to take back the control for just a second, and next we're gonna talk through, I think, Rajashree's section. So let me just make myself the presenter and show my screen. And so we're going to talk about now our multi-tenant application catalogs. And this is, Rancher has long had application catalogs bundled into it, and provides the ability to have lots of application catalogs for different uses. But up till now, those catalogs were all kind of either private or public. There wasn't really any concept of, different levels of sharing of your catalog. For example, sharing my catalog with members of, a couple teams that I work with, but not necessarily with everyone. So it was either a catalog was public or private, and now we've introduced the concept of multi-tenancy and shared catalogs across different levels. So Rajashree, are you ready to present on this?
Yes.
Okay, I will make you the presenter.
Okay, can you see my screen?
Yes, I can.
Okay. So once again, welcome everyone to the meetup. And I'll be going over the 2.2 feature that lets users add catalogs at the cluster and project level. But before that, I just wanted to quickly go over the benefits of Rancher catalog and what it is. So in Rancher, you can add application catalogs, which are nothing but repositories containing Helm charts or Rancher charts. And a Rancher chart is an extension of a Helm chart. So once you add these catalogs, any users can install Kubernetes applications that are present in the charts from these catalogs. For those of you who aren't familiar, Helm is a package manager for Kubernetes applications. You can think of Helm, like Helm is for Kubernetes, what Homebrew is for Mac, or how apt-get is on Ubuntu. Helm gives an efficient way of installing applications in your cluster. There are many applications such as Nginx or MySQL, which get frequently used in Kubernetes clusters for different other applications. And a lot of such applications have already been packaged through Helm. So instead of writing your own manifest to create them, you can just run a single Helm install command and have those applications running in your cluster. Any application, any Kubernetes application that is packaged in this way is called a Helm chart. And a chart repository is a collection of such charts. So when you add this chart repository to Rancher, we call it a catalog. I think Helm is amazing because as a developer, if say I need to install MySQL app for one of my applications, I don't have to create my own manifest, nor do I have to copy paste some existing manifests and run them through the kubectl create command. I can just install it with a single command. Also, the way it handles dependency is amazing. Another important feature, I think, is the version control of apps that Helm provides us. You can release different versions, upgrade to a newer one, or roll back to the previous one. And there are many tutorials and great documentation online on managing your Kubernetes applications on clusters with Helm. But when it comes to managing your apps on a multiple cluster setup, there are many things that you'll have to take care of. Since Rancher has to manage multiple user clusters, we handle Helm and Tiller a little differently. So we basically have a fork of community Helm, and we built our own Helm and Tiller binaries and packaged them into the Rancher server. Now they don't differ much from the upstream binaries, but Rancher Helm provides a lot of advantages for managing your apps in a multi-cluster setup. So let's say you're managing multiple clusters. Helm CLI uses the kube config to point to the right cluster for app installation. meaning you'll always have to manage context switching between these clusters each time you have to install an app. And this might seem like a lot of work, especially when the actual installation can be done with one command. Also, you have to secure your tiller installation. Tiller is the server-side component of Helm, and it is usually started as a pod in the KH cluster. And one of the main ways of securing it is through creating a service account for this tiller pod. And it is extremely necessary to have proper permissions for tiller because it can launch, update, or delete apps. So you don't want an insecure installation where any user can delete an app that other users could be using. And so since Rancher does the job of managing multiple clusters, it can also take care of all these things related to launching the app in clusters or RBAC for tiller. So the RBAC for tiller is done via user impersonation. When you start your Rancher server, either local auth or some external auth is enabled. So only users that the admins grant permission to Rancher can log in. And once a user logs in and tries to launch an app, we create a token for this user and we maintain it for any future requests. Then we get the context for the current cluster. This way we know from whom the request is coming and for which cluster. And this token is then set as an impersonation header in the API server request. Since Rancher, like I said earlier, is managing the multiple user clusters, we can also get the context of the current cluster, and you don't have to take care of that either. Also, instead of starting tiller as a pod in each user cluster, we start tiller as a process per app installation. And this also makes the app installation parallel, possible in parallel. So this is kind of just the high-level diagram showing how it's done. So we run a Helm controller per user cluster. And if a user tries to create an app for one of these clusters, the Helm user controller will start the tiller process for that cluster and app installation will take place. So Rancher, Helm, or Catalog has a lot more advantages. Some of them include how we cache all the charts as soon as you add a catalog. So we prefetch or download these charts from these catalogs and save them in some of our CRDs. This reduces the latency when you actually want to launch an app. You don't have to go look for the exact catalog. You already have those charts present and their different versions also are made available to you. And the second advantage is, of course, the UI. I think users have a lot of great things to say about the Rancher UI in general, but especially for catalogs, you can easily list the different charts you have available per catalog and the different versions. You can just select which version to deploy. Also, it tells you when an upgraded version is available, so you can upgrade to that. So on the very first slide, I said that Rancher catalog is an extension, the Rancher chart is an extension of a Helm chart. And that is so because Rancher chart has two additional files to the that we add to a Helm chart. So the first is the app.readme, which is just a more detailed description of what the chart exactly does. And it is presented in the Rancher UI when you go to the launch applications page. And the second one is questions.yaml. So when you're installing an app, you can provide values for some of your variables, such as, say, image tags or other such things by passing answers. But you have to pass all these answers in key value pairs. There could be multiple such variables. And Rancher makes passing these answers to the chart easier through questions.yaml. So instead of typing out key value pairs, the UI presents you with a form containing all these questions that you can just provide your answer to through entering a value or selecting a radio button. So this further makes the app installation easier. And now the Rancher application catalog. So the way you can add any chart repository containing Helm charts or Rancher charts is through adding a catalog. Yeah, so you can either just add an existing Helm chart repo, or you can create your own GitHub repository with these charts. So I think I'm just going to show you first how at the global view you can add a catalog. So for that, at the global level, you can go to Tools and Catalogs. And over here, you can see that the library catalog, which is like the Rancher catalog, is always enabled by default. Over here, you can click on Add Catalog and provide any name, whatever catalog URL you want, and create a global level catalog. Once this catalog is added, like users from all projects have an equal access to the charts in these, like in this catalog. So, like once the global level catalog is added, all users have the same access to the charts from that catalog. But there are use cases where people could require isolation between these catalogs at a cluster level. For example, some companies could be running Rancher in a way that one cluster is dedicated to one team or even a customer, and they want certain catalogs and charts to be available only to that cluster and to be hidden from the other clusters. So that's why in 2.2, we added the feature which will let you add catalogs at a cluster level. And also the same kind of requirement arose at the project level as well, like to provide further isolation between catalogs at the project level, because different teams could be operating in different projects of the same cluster. Hence, in 2.2, we have this feature which will also let you add a catalog at the project level. So once you add a catalog at a cluster level, only users, the cluster members or cluster owners from that cluster can see the charts from that cluster level catalog. And same for the project level catalog. Only users from that project will be able to use the charts from this project level catalog. So let's go ahead and add a cluster level catalog. Before that, I'll just go to one of my projects. And over here, I'm on the launch application. Like if I try to launch an application, I can see there's only one catalog available to me right now. So I'm in my first cluster. Over here, I'll go to Tools. And under Tools, I'll go to Catalogs. Now I'll add a catalog here. And again, while adding a catalog, if it's a GitHub repository, you can provide any different branches that you may have. And as you can see, the scope is cluster because I'm adding this catalog for this cluster. So now when I go to launch an application in this project, yeah, I should be able to filter out between catalogs. So this is the global catalog that was available earlier, and this is the cluster level that I added. And now I can launch apps from like both of them. And now for the project level catalog, you navigate to your project. Then again, you go to the tools section, and under that you click on catalogs. Now this is the exact same format. You can provide your URL and branch. And now if I go to launch an app, I should be able to see all three catalogs. And yeah, so now any users who are who have access restricted only to the second cluster, they won't be able to see any of these two catalogs because they don't belong to this cluster. And yeah, I guess that's it. That's all I wanted to share. Also, if you need to follow the documentation for adding these catalogs, you can go to Rancher Docs, Catalogs and Apps, and under that you can go to adding custom catalogs.
Awesome, Rajashree, that was really good. Thank you for going through that. I think there were a number of questions, but I think we were able to answer most of them using the Slack. So if anyone has any other questions for Rajashree, please fire them away, and she'll be in the questions channel answering them for you and adding more to it. But with that, yeah, thanks a lot, Rajashree.
Thanks.
Just switch back over. Okay. All right. So we talked about multi-tenant catalogs. The next thing we're going to do is Prachi is going to talk about two topics. She's going to talk about something that we just announced about a month ago, and when we sort of released it to alpha, a very cool approach to running applications across multiple clusters. We did a whole meetup on this, so if you want to dive into it in a lot of depth or talk, hear a lot of different use cases for it, you can kind of go to our YouTube channel and see a lot more. But this capability is really, kind of going to be driving a lot of capabilities in the future as we look to a world where Kubernetes is not a single cluster, big Borg-like thing, but rather Kubernetes exists in lots of different places on lots of different deployments and the edge and the data center and the cloud. And the idea for applications or services to be almost like daemon sets and deployed to all of them is really important. There's also a lot of great use cases for building apps that themselves are running across multiple clusters. And this is the first step in that path. There's a lot more potential stuff on our roadmap to actually make multi-cluster applications, kind of really push forward what's possible around DR and such. But for now, we want to kind of dive into multi-cluster apps and then talk about what we're doing on DNS. So Prachi, why don't I turn it over to you and you can start presenting and talking about the data.
Yes, Shannon, sure. Do you see my screen?
I do, yeah, go for it.
Okay. Hi everyone, I'll be covering the MultiCluster App and global DNS features that are introduced in Rancher 2.2. So to start with, I'll go with the feature highlights. For MultiCluster App, the feature is providing a single global interface to deploy same application from a catalog to multiple Kubernetes clusters. So before 2.2, Rancher has the capability where users can select an application from a catalog and deploy it to a cluster. But we are taking it to one above level. We are taking it to the global view where user can select an application from a catalog and also choose multiple target clusters to deploy the same application. Users can choose the clusters and projects to schedule this application and also customize the configuration of that application per target cluster or project. Now this feature is Kubernetes provider agnostic. So the app that you choose from catalog can be deployed in clusters no matter how the clusters are provisioned. Internally, MultiCluster App is using the Helm lifecycle support. So all the cool features of Helm deployment, upgrade, and versioning are available for MultiCluster App to make the deployment and management of the applications easy. The other feature that I'm going to talk about is global DNS. So global DNS helps you to program an external DNS to route application traffic to endpoints that are present in your cluster. With DNS, this is one step further that you can achieve high availability for your application. And it can be also useful to achieve low latency for your application based on DNS resolution for certain DNS providers. This is a graphical representation of what I just talked about, where basically the feature workflow is that for both of them is user selects an app from the catalog, and for MultiCluster App, the user further has to select target clusters or projects to which the app should be deployed. And Rancher MultiCluster App controllers will invoke the Helm lifecycle to take this application configuration that user has set and deploy it to each Kubernetes cluster that the user just chose. Along with MultiCluster App deployment, the global DNS controllers that are running in Rancher can help you to go and program an external DNS server like Route 53 for your application endpoints that are in various Kubernetes clusters. Now, what are the use cases that these two applications are helping to solve? So, applications that need high availability, for that MultiCluster App and global DNS can be used. If your clusters are positioned in different geographical regions, you can ensure that the same deployment of the application exists in these multiple clusters. So even if one particular cluster has gone down or your application in a cluster is not responsive, the same application which is residing in other Kubernetes cluster can take on the user load. It can be used to spread the load across the clusters. With programming an external DNS, you also make sure that endpoints from various clusters are all programmed against a single FQDN, and your application can be accessed in a uniform way. Other use case is for routine IT operations, where admins want to push same applications for managing the cluster, for security of the cluster, or for general management of the cluster. If they want to deploy certain applications to a large number of clusters, it is usually a time-consuming and error-prone job. So using MultiCluster App, this can be done in a reliable and efficient manner. Now, the cases where users also want to avoid cloud provider lock-in, they don't want to use the same Kubernetes provider for deploying their applications, they can use MultiCluster App to make sure that copies of their applications are available on Kubernetes clusters which are provided by different cloud providers. Other use case which is important that can be solved is all the edge computing cases, where you want your users to be served by clusters which is closer to their location and to have some low latency. Then MultiCluster App can be used to deploy the application onto the very large number of clusters in order to reach the user from which are closer to them. Now, with these use cases, I'll move on to how the MultiCluster App and global DNS features work with Rancher UI. Now, user can use Rancher catalog or add their custom Helm catalogs for selecting the applications. Under MultiCluster App, this is a feature that is available at the global view outside of all the clusters. So users can launch an app from the catalogs available and then choose target clusters or projects to deploy. And Rancher will make sure that the same application gets deployed to all the cluster targets that you have selected. You can also go and configure the application differently for each target. Then users can upgrade, rollback, delete the MultiCluster app after it has been launched, and this action will be applied to all the applications deployed in each target cluster. To use global DNS along with MultiCluster app, user need to use a particular annotation, rancher.io/globaldns.hostname, and put this annotation on an ingress fronting your application. The value of this annotation should be the FQDN that you want to program on the external DNS. After this is done, Rancher will take care of programming that FQDN on the external DNS provider that you have configured. For global DNS, user needs to deploy two entities to start with. First is you have to launch a global DNS provider of your choice so that Rancher knows how to talk to the external DNS server of your choice. All the providers from Kubernetes Incubator external DNS project is what Rancher is supporting. So currently with Rancher 2.2, Route 53 and Cloudflare have been enabled along with LEDNS. Now user after configuring the global DNS provider can go on and create a global DNS entry. Using a global DNS entry, user has to basically is telling Rancher what is the FQDN that Rancher should go and program, and then what are the target IP addresses that have to be programmed under this FQDN. So choose the FQDN and choose the target MultiCluster app or the project. So when any ingress running in the user clusters uses this particular annotation with the FQDN that you have already recorded in the global DNS entry, Rancher will use that ingress IP addresses and program it against the FQDN. Rancher controllers will make sure that they will keep on consolidating the endpoints from all Kubernetes clusters which are getting programmed under this FQDN. So if your application in one cluster goes down, or if if new nodes are being added to a particular cluster, then new IP addresses are available under the ingress of your application. Rancher will make sure that those new IP addresses are picked and then programmed on the external DNS. So with this, I'll move on to demo so that I can explain this workflow in a better manner. So here we have Rancher 2.2. Now this is at the global level where all the clusters that I have added get listed. At this global level with Rancher 2.2, there is a section called as apps introduced, and under apps, all the multi-cluster apps that the user will launch will get listed. So in order to launch a multi-cluster app, I can first make sure that my application is available via catalog. If I want to add a custom catalog, then I can do so by adding my catalog. Once my application is available via Rancher catalogs, I can go to the launch. We are at the global level, so whatever application that I choose here, for example, I'll choose the Grafana app. Since I'm at the global level, Rancher UI will give you an additional option of selecting target clusters or projects to deploy this application to. So I'll choose this Grafana app, and then I want to deploy this to say 2 Kubernetes clusters that I have. So I have this project 1 and under one cluster, and then I have project 2 under another cluster. Further, I can choose the upgrade strategy if I want to go on and later change my multi-cluster application, then I can select whether I want to update applications in all clusters at the same time or I want to update them in a batch. With multi-cluster app, RBAC is also available. We provide role to the multi-cluster app, either the project role or the cluster role. What this defines is if your app needs to access some resources at the project level, make sure that you are providing a project role to your app. If your app is going to access resources outside the project, then you make sure that your app has the role, cluster role, so that it can access all the resources in the cluster. I know that my Grafana app needs to access some resources within the cluster, so I'll give it a cluster role. Further, you can specify these configuration parameters for all the targets, or you can go ahead and make sure that you want to override the configuration per target cluster or per target project. Then you can override it using the answer override section over here. Multi-cluster app also provides support for RBAC. So if you want to create a multi-cluster application and also share with other users for, say, managing them or listing them or monitoring them, then you can select members from your organization, add them to the multi-cluster app so that they can also view and manage the application. After doing this configuration, when you launch this multi-cluster app, Rancher controllers are going to use the Helm lifecycle to go and deploy this application to each target project that you have selected. Now, I already have one application that I have deployed. So once this application gets deployed and goes to active state, what you can see is both the targets. You can drill down to each target project. Oh, my demo app is already active. I can drill down to each target project. So here I have drilled down to the cluster under which I had deployed, and under apps, this instance of this multi-cluster app gets listed. All the workloads that got deployed on the cluster get listed under the workloads tab. Going back to the global view under apps where my multi-cluster app got listed here. If I want to go ahead and say upgrade my multi-cluster app, I can choose the upgrade option, where I can go and change configuration of the application. I can do so per individual target project as well. And after upgrade, what it does is revision gets created for that multi-cluster app. And later on, if you want to roll back to that revision, it can be also done using the rollback option. This is about multi-cluster apps. Along with this, I'll also demonstrate the global DNS, and then we can come back to multi-cluster app and see how I can go and program the DNS for this application that I just launched. So to use global DNS at the global level, under the Tools tab, we have global DNS providers and global DNS entries. So first thing to do is you have to go and configure a global DNS provider of your choice. So I've already configured, I have added a DNS provider for AWS Route 53. For each provider that we have enabled here, what you need to do is provide the root domain and any credentials that you need to provide Rancher to go and talk with that provider. So for Route 53, I have already provided my root domain of choice and my AWS access key secret keys so that Rancher can go and talk to my AWS hosted zone. After the DNS provider is launched, next thing you have to do is add a global DNS entry. Under the global DNS entry, what you are going and doing is you are recording the FQDN of your choice. And for example, for my demo app, suppose I want to go and program an FQDN. This is my hosted zone. So suppose I want to go and program an FQDN on this hosted zone for my demo app. I use the provider Route 53 and I say that this FQDN has to resolve to IP addresses in the MultiCluster app and select the MultiCluster app that I just launched. What this will do is basically Rancher is going to use the IP addresses from your MultiCluster app demo from all the cluster targets and then go and program this against the FQDN that you have just provided on the Route 53 provider. So I'll create this global DNS entry. One more thing that I want to demo here is, if you don't have a MultiCluster app, you can still use global DNS separately. So for that, you have to provide an FQDN, and then instead of MultiCluster app, you can just provide it what are the target projects under which Rancher will go and look for an ingress to choose the IP address to program. So these two features can work independently of each other as well. Now I have created this global DNS entry. I have to make sure that I put an annotation on my MultiCluster app ingress. So I'll go and under the MultiCluster app, I can upgrade the app that I just launched. And this is a chart coming from my custom catalog, which I have already went and edited to provide a configuration parameter, which goes and updates an ingress in my chart. This is basically putting an annotation with this value on the ingress in my application. And then I upgrade this MultiCluster app. What Rancher is doing is, it is doing the upgrade for all the applications under each target project. Once it is active, if I go and check my global DNS entry, which I created, I can show it an API. It got the IP addresses from my 2 target clusters. These are the IP addresses of the ingresses running for the MultiCluster app. You can make sure on your Route 53 or the provider of your choice that these 2 IP addresses or this FQDN gets programmed on the external DNS. It takes a while, but for an entry that I had already created, you can see that the FQDNs that I provide get programmed on my Route 53 provider or Amazon. So this is the way you can use these 2 features, MultiCluster app and global DNS. With this, Shannon, I can move on to any questions. Are there any?
Yeah, thanks, Prachi. That was great. There's been a number of questions actually that have been coming in. Rajashree's been answering quite a few of them, and Jason has as well. There was a question from Daniel. He said, could the global DNS specify your front-end load balancer before the cluster? If that's possible?
Right now, global DNS, we are using the Kubernetes Incubator's external DNS project, which looks for ingresses. And we are using that. So we are not picking up the front-end load balancer at this moment. We are working with ingresses.
There was another question about the different load balancers that were supported. A number of people asked about Azure DNS, Google DNS. Do you know if, I know there's a plugin framework for these to be added, but Can you talk about any that we're working on or any that you know the community is working on?
Yeah, so what we are Global DNS works with is the Kubernetes. This is the Kubernetes Incubator external DNS project. So whenever you launch a global DNS provider from a UI, what we are doing is we are using the provider implementation from this project and launching that as a Kubernetes deployment. So all the provider support that is available in this project can eventually be enabled via Rancher. Right now with 2.2, we have enabled the support for AWS Route 53, Cloudflare, and LEDNS. But with a minimal code change and I think hopefully with using a pluggable framework in future, we can go and provide the support for all these providers which are present in this project soon.
Great. So you expect, could other people introduce their own things there if they had like, there was a question from Stefan asking if anyone was working on a plugin to enable this for internal DNS servers. If they had their own DNS service, could they connect to that?
In order to, yeah, they can activate that, but they will have to make sure that their custom provider implementation is basically submitted upstream to this Kubernetes incubator project. And then from there, we can enable it in Rancher.
Great. Another question came from Tony. He said, what's being done on the back end to achieve the multi-cluster app deployment? And then asked if stateful applications like MariaDB could be supported in a multi-cluster application.
So the first part of the question, what is being done? So internally, when a multi-cluster app is launched and you are selecting a target cluster, we are using the Helm lifecycle. So our Rancher controllers are basically choosing the Helm chart that you have just configured and using Helm to create the deployment on your Kubernetes cluster project that you have chosen. And for multi-cluster app, we repeat this process per target cluster or per target project that the user has chosen. In order for the second part of the question, if you want to use stateful application, you have to make sure that your stateful application chart is available in the Rancher catalog, and then that it can be deployed in the Kubernetes clusters. But then each application is just so each cluster gets a copy of that application. So it's not like your application your DB is in one cluster where your application web server is running in another cluster. So with multi-cluster application, the same deployment copy gets created in all the target clusters that you have created.
Yeah, there's another use case for that last one, Tony, which is if you're doing something like that, you might want to look into the project Submariner that we announced a couple of weeks ago. Submariner, the key to doing that is kind of creating an overlay network between the two clusters and allowing things like, multiple shards to exist in different clusters. That requires kind of a consistent overlay and encrypted funnel between the clusters, and that's what Submariner does. And there's other ways you can do that, as long as you have the components, though, something that actually implements like a cockroach DB or something else that's actually distributed across clusters is definitely where we see a lot of this heading to. Is the other area there's going to be we'll be announcing some things later this summer around persistent storage, DR and backup across multiple clusters, and some really interesting things we've been working on there. So good questions. A tool asks if the DNS and load balancer can be integrated with external tools like F5 and Infoblocks.
So the global DNS project is exactly for that, but I think if you're looking for F5, right now with Rancher 2.2, we are supporting this global level feature for DNS programming only, for external DNS servers. I think F5 is the global load balancer story that Rancher 2.2 doesn't have, but I think using the same path in future, hopefully we can also support an external load balancer.
Right. Jackson asked a question about Azure and EKS, and let me know if you can answer this. He asked if with ingress on EKS, Amazon's Kubernetes service, it creates an ELB on AWS without a fixed IP, but a DNS record. Would Rancher be able to update these DNS records on CNAMEs using Route 53? And do you know of anyone using the Route 53 functionality with an EKS cluster to get around some of the limitations there? And maybe Jason, you can add to that if you've run into that as well. But Prachi, can you talk to that at all?
So one thing I can note here is I think the global DNS that we have here is looking at for ingresses in Kubernetes clusters. So if you're using ingresses to front your application, yes, we can program that ingress IP address onto Route 53. But if you're using a load balancer service, right now we don't look at that. The global DNS feature only works with ingresses.
Great. Okay, another question that came up was from. Oh yeah, Jason, did you want to add to that?
No, I think she covered. I think she covered it really well.
Okay.
The underlying implementation, external DNS, does support therefore service level annotations, but I don't believe we're surfacing that in this release.
Got it. I think that's probably enough for us to kind of answer the rest on here. Thank you so much, Prachi, for covering all of that. Let me switch back to myself, and we'll go through our last section on this, which is really focused on cluster backup and DR. And this is about maintaining backups of your etcd instances and data. And this is some work that Hussein has led and the team has been working on for a while. I'll let Hussein get into it in some detail, but it's really about how to snapshot etcd, how to schedule those snapshots, how to recover from those across, again, all of your clusters everywhere. Hussein, you ready to present?
Yeah.
Great. Let me make you the presenter, and you can dive in.
Yeah. Can you see my screen?
I can see it just fine. Yeah.
Okay. So, hi everyone. Let me introduce a new feature that we have in Rancher 2.2. So, if you are familiar with ArcE, you know that previous to ArcE 0.2 or Rancher in Rancher 2.0, we had ArcE snapshots, which basically we were able to take etcd snapshot and restore them on nodes. But in 0.1, ArcE had a few problems with backups and restoration process. We had a problem with syncing backups. We didn't have remote backups, and the restoration process was very manual process and really prone to errors. So introducing 2.2, we added backup and restoration process into Rancher clusters. So now you are able to take backups for etcd nodes and restore them directly in the Rancher UI. To do that, we had to optimize the restoration process, and we had to optimize the backup process in ArcE first, and then so that the Rancher can easily use them in the backend. So we added few features, including S3 backup. So now you can restore and save snapshots on Amazon S3 or any object storage that uses S3 interface. We added also a syncing process for local backups. So now if you take a backup on 3 nodes, they are synced automatically. You don't have to intervene manually to do any syncing steps. And we added a recurring snapshots directly in Rancher UI. So Rancher itself checks every 5 minutes and make sure that a recurring snapshot process is running and takes snapshot if it's due. So let me directly dive into a demo and show you the process for taking backups and restore them. So here I have 2 clusters, a local cluster that basically uses local snapshots and one that uses S3. So let's let's first check the local clusters. So if you create a new cluster, you will notice that in tools, you have a snapshots tab. If you click on it, then you will see there is a local snapshot directly created when you create the cluster. So the local or recurring snapshots is enabled by default. So if you go to edit cluster and go to the advanced option, you'll see that recurring snapshot is already enabled by default, and it's configured as a local snapshot, so it's taking backups on the local nodes, and it's configured as for taking a backup every 12 hours, and it has a retention count of 6 backups, which means it only saves 6 backups on the node. After that, it deletes any extra backups when it takes them. So let's try to take a backup. First, let's create a few workloads. So just creating Nginx pods, like 5 pods. Okay, so after that, we will attempt to take a snapshot. So after you click on a snapshot, now you'll see the message that says that it's already taken a snapshot. You can check in the backend in the logs that it's connected to the 3 nodes and already saved the snapshot on all etcd hosts. If you go to tools, snapshots, you will see that a few seconds ago, a snapshot were taken locally on all nodes. Okay, so let's now delete the workload that we just created and try to restore the backup that we just took. So we expect that we see the workload of Nginx to be restored on the cluster because we did take a backup when the workload was present. So we'll take we'll now go to edit. Go to the 3 dots for the cluster and click on restore snapshot, and then we will see that we had 2 snapshots. One, this is the recent one, and we will click save. So the cluster will update and will basically try to restore this snapshot in the backend. So as we said, it uses ArcE in the backend to restore this snapshot. Yeah, this few errors because we restart the kube API as we restart the etcd. So let's wait a minute or so until the backup is restored. So I have to note here that the backup that was taken, it was taken on the 3 nodes that was created. So when restoring this backup, a syncing process is created and automatically sync the backup between 3 nodes, because you can't take a backup with different timestamps on every node because it will have a different draft index and it may cause an error. So that's what happens in the backend. Okay.
One of the questions that have been coming in, Hussein, there were 2 of them from different people. Frank and Josh kind of asked about what about non-RKE clusters, like if we have a cloud provider-based cluster or a imported cluster. Do you know if any of those also can be backed up?
So right now, no, you can't take a backups for any other cluster than RKE clusters. But for imported cluster, if it's already generated by RKE, then you can use RKE CLI to take backups and restore them. However, for any other cluster, you can't really take a backup directly from Rancher UI.
Great, thanks.
No problem. Okay. So we can see that the restoration process is already running, and make sure that all services are in a healthy state before starting the cluster. Okay, so the cluster should be in a ready state now. Let's check the default project, and we should see the Nginx. Yeah, we should see the Nginx deployment is up and running and restored. So this was the local backups. Let's check the S3 backups. So actually on the same cluster, we can demonstrate how we can enable S3 backup. So you can go to edit and then go down to advanced option and then select S3 instead of local backups. So I already have a bucket name, and you can just copy the S3 access key and secret. And for the S3 endpoint, we add the default S3 Amazon endpoint, and we click save. So the cluster will update briefly and will configure S3 as its main endpoint backup. So I should note also that you can use main.io instead of Amazon S3 if you have your S3 server. You will change the endpoint and you will add the key and secret key, and you will be able to upload directly to this server. Okay.
And Hussein, if we wanted to change that to point to, for example, Azure or Google or a Minio running on-prem, all of these things that support an S3 endpoint, how would we do that? How do you actually point it to some other non-AWS service?
You can just change the endpoint here. Instead of S3 Amazon AWS.com, you can just change it to the endpoint that you have for Min.io or Azure or anything else.
Great, thanks.
Okay, so now we configured S3 as the endpoint for the backup. So if we take a snapshot now, then we will see that a snapshot has been taken, and we can see in the backend that it's taking a snapshot for the cluster and saving it on S3. So we can check the Amazon S3. This is the bucket that I have that I configured. And as you can see, a backup was just created for the SD. So the restoration process is actually the same. You can just restore a process, restore a snapshot from a S3 backup as the local backup. It's exactly the same. So I think that's all of the feature. Is there any question, Shannon?
Yeah, there was a couple. When we've been answering a lot of them as you've been going. When Nikhil just asked, he said, if I didn't create the cluster, can I edit the S3 backup configuration? For example, if I'm an administrator or I have some privilege within Rancher, I mean, that shouldn't be a problem, right? As long as I'm the admin, I can modify this within Rancher, as long as it's created through Rancher and it's an RKE cluster.
Exactly, yeah. As long as you are the cluster admin, then you can modify the S3 endpoint to modify the snapshot configuration to S3 or local backup or whatever.
Got it. And when there was another question that we answered, but it might be interesting to talk about, just if I've lost access to the cluster, obviously, and I want to do a restore, Rancher itself would be running on a different, is running independent of the cluster. So the assumption is I still have access to Rancher if I want to restore the cluster. Is there, if I have both of these things down, is there any manual way to pull the backup and recover from that you have documented, or you can walk people through? Like, what happens if, let's just say, Rancher is offline and the Kubernetes cluster is, has a backup problem? What would your approach be to getting the raw backup and recovering from that?
So we already have a documented process for backing up and recovering Rancher server itself. So this is a slightly different steps for single node installation and for the high availability node installation. So you can check out the documentation for both of them. For the high availability node installation, we use RKE CLI, snapshot, and restore. And for the single node installation, we just run some Docker run command that saves a snapshot locally on the Rancher server. So first, you restore the Rancher server and you access the Rancher server, and then you can after that restore the snapshot if you have it on S3 or on local for any user cluster.
Okay, great. Well, I think we'll probably park it there. And if you have more questions, Hussein will be on answering them as we go through. But Hussein, thanks a lot for covering all of that and going through so much of what we've been doing on the BDR side.
No problem.
So with that, I think we'll start to kind of wrap up. If you haven't already, you can go get to our quick start guide and set up Rancher 2. You can easily find the version. The one thing that there was a question about that I wanted to kind of stop here and maybe ask Jason to talk through was the upgrade process. For those of you who are running on 2.1, or maybe you're still on 2.0, you never upgraded to 2.1, upgrading Rancher is itself very easy. The Rancher service is just deployed as a Helm chart on Kubernetes, or as a container on a single node if you're just running a single node config. But it may be worth kind of just talking through that really quickly. And I don't know if there's anything you want to explain or demo or some docs you'd want us to show, Jason. But you want to talk through the process of upgrading if people have any questions.
Sure. Let me actually I can pull up our docs and talk through that.
Great. Why don't I make you the presenter for a couple minutes and you can just talk through it. You should now be the presenter.
All right. Can y'all see my blank screen?
I do.
All right. So if I go to docs.rancher.com or rancher.com/docs, because that's where it ends up, and go down to read the docs, we have great documentation around upgrades of Kubernetes bits and of Rancher itself, depending on your setup, whether it be a single node install or an area app install or an HA install or an HA area app install, or even migrating from our older RKE add-on installs, which were pre-208. But generally, it's a Helm chart change. So if you were to look at a single node install, because it's a Docker run command, you have to back up the volumes in Docker. Using you'll basically create a data container. So you'll take a backup of the existing container and the volumes from. Then you'll do a Docker stop of the existing container, and then you'd create a volume container from the existing version, and that would have all of your data for Rancher in the volume container, and then do a Docker run with the volumes from command with the new version of Rancher, and that would upgrade your Rancher version in a single node. In an HA scenario, it's very similar, except you're just changing the Helm chart command. One thing I'll note that I see it as a gotcha out in the field. There's not a whole lot we can do about it because it's just the nature of Helm. Is that when you're setting your key value pairs in Helm, make sure you're including all the set values that you used during the initial install. That's really important in a Helm upgrade. So that's the big thing I would lay out in the HA install that is not there in the single node install. As far as upgrading Rancher or updating the Kubernetes version in an RKE Rancher, I believe mine might be totally up to date, but we can check it anyway. So if I edit this cluster here, This is an RKE-based cluster that is living in DigitalOcean right now. It is simple. It is really as simple as changing this dropdown, selecting the new version of Kubernetes, and hitting save. And then it will actually roll through and upgrade the various containers under the covers. These are all Hypercube, which is a community-supported open-source project that has all the Kubernetes processes in one container. So we're using an upstream container to do that, and as we support new versions. Now, currently, a Kubernetes upgrade requires a Rancher upgrade. That will always be the case. We're actually working on that now to do out-of-band Kubernetes version updates, because right now, it does require us to actually upgrade Rancher and upgrade Kubernetes.
All right. Anything else you want to show, Jason?
In and around upgrades, that is good. Now, if you do wish to move a cluster and upgrade it, this question came up in the questions. I answered it on text, but I'll answer it here as well. If you're looking to move a cluster to different hardware, at the end of the day, it's an etcd backup. Etcd is the brains of Kubernetes. If you look at the underlying architecture, it's actually one of the better graphics created by the community on the hardware. So here, etcd is your brain. The only thing it talks to is a kube API server. So whether you're backing up a Kubernetes cluster or an HA Rancher cluster, backing up etcd and restoring etcd to new hardware would have the same effect. Now that also means you're going to have to, in an air gap scenario, you're going to have to move all of your images over. In a persistent storage scenario, your persistent storage backups would be separate from anything Kubernetes related or Rancher related. But by and large, backing up and being able to restore that brain of Kubernetes is really how that would work.
Great. Hey, one other thing while you're showing it, there was a couple questions about what versions of Kubernetes and things like that are supported. Do you want to mind pulling up the latest matrix, the latest support matrix of versions of Docker and Kubernetes?
And then let's see. I always forget where this is off the top of my head. It's in our terms of service too.
I think it's in the terms of service. Yeah, that's the easiest place to find it.
Yeah. All right. Let's go to the docs.
Not docs, but just the rancher.com. Yeah.
Oh, down at the bottom.
Yeah, exactly.
There it is.
Just go to
Terms of service.
Yeah. It's also docked in there as well. But if you click on that one, it should show you it. But you're still under docs, I think, aren't you? Oh.
No, I just hit the legal terms of service down here.
Oh, okay. Is it taking it?
It's waiting. Might just be my connection.
Yeah, that's fine. Anyways, it's pretty easy to find. We'll put it in the questions thing. All right.
Yeah, I think I've lost my network connection, so I'm dialed in via the phone.
No problem. All right. Thanks. Thank you so much, Jason. So the good place to start is the quick start guide. Certainly in the docs, you can find version information. Right now, it's basically 1.11, 1.12, 1.13, and expect 1.14 very soon. The other area, obviously, to get all your information is GitHub. All of Rancher and RKE and K3S and everything we do is in GitHub. You can find it Rancher/Rancher. If you're not already there, if you haven't already, please kind of jump in there. Feel free to start filing issues if you're running into them or suggestions. If there's things you want to work on, just put in an issue and let us know what kind of ideas you have. If it's for more drivers or more integration, there's a lot of opportunity to contribute with all these different plugins and ways to extend Rancher. Also, Rancher, like we're past 10,000 stars not too long ago, but throw us a star and give us your love. We certainly appreciate it. With that, I will thank you all very much for your time. It's been great. Thank you all for presenting today. Prachi, Hussein, Jason, Rajashree, thanks for all the work on 2.2. Everyone in the community who helped and contributed issues, contributed fixes, contributed docs. Thank you all so much for your help. And with that, if you have more questions, you can always email me, Shannon@rancher.com, or find me on Twitter at SMW355 or on our company Slack or the Kubernetes Slack. We're kind of all over the place. So feel free to hit us up if you have more questions. And with that, we will see you next month. Have a wonderful day. Take care. Bye-bye.